Welcome back to CS201 walkthroughs. Today we're going to be walking through practice midterm 2. I haven't really looked at it, so again, it might be a little bit rough, but I'm going to try to walk through it and hopefully I don't get too much wrong. And even if I do get something wrong, maybe that will give you an idea of what to watch out for. So problem 1a asks for, let's read it really quick, plus times expression, which is defined recursively, where a bracket number is a plus times expression, or a list containing 3 elements, where the first is a plus times expression and the last one is, and then the second element is the symbol plus or the symbol times. So I think here it seems pretty easy, but we're going to have to be a little bit careful about like some edge sort of cases. So let me see if I can define something that takes those into account. I might miss a couple. So define PTX, I think probably just takes exp and expression. Is that right? It takes a value. Okay. The first thing I'll check is if it's a number, because if it's a number, it's good. That's the base case. So if, maybe I'll put it in the con, because I think I'll have a few conditions here to check. So con number value true. Then we have to check, let's make sure it's a list of length 3, I guess, right? Because that's an important part. Or maybe if it's a list at all, so something like, because I'm going to start getting the catter and the car and the elements of it, and I can't do that if it's not a list. So maybe I'll check if not list, check some, some tricky inputs, value, then is false already. Now we know it is a list. If not, let's see. Or how about I check if the list length is equal to 3, then I'll do some stuff and I'll have an else false. So here I'll say equal length value 3. Then I'll have another, I'll say, let's see, what's the most efficient way to do this? Yeah, maybe I'll have another cont. A little messy, but we'll get through it. Or I can just have an and, right? So we know the list length is equal to 3. I'll say and these are all going to be my true or false values. So and PTX question mark car value and PTX question mark the car of the cutter, so the catter value. And or equal plus catter value equal times catter value. Times catter value, close equal, close this or, close this and. I think and takes 3. If it doesn't, I could just add another one. And then close this conditional statement, and then I'll have an else false. Okay. And then I'll close my conditional statement here. And I'll close my define here. I think this works. I hope this works. Let's move on to 1b and see if I can do that in this video too. Okay, so this just evaluates the plus times expression. I think we can do that. So remember, it takes a plus times expression already. All we have to do is evaluate it. I don't think there are too many edge cases to handle here, right? Because it's just, adding and multiplying stuff together. We already know it's a PT expression, right? It says takes a plus times expression as defined. Okay, should be pretty easy. Define, this is now 1b, and it's going to be called evaluate expression. So define evaluate. Again, we're going to have a con that says if it's a number expression, return that number, which is expression. If it's not a number, it must be a list of length 3 with either a plus in the middle or a times. So I'll say equal cadder expression plus. In that case, I'm going to add. So here the key here is I'm not adding the car and the first and the third element. I'm actually going to be adding what I get when I evaluate both of them. Okay, so I need to make sure I say plus evaluate. I'm going to try to make this easier for myself with first expression and third expression. And if it's times, I just need to multiply them. So equal cadder. Actually, I don't even need it. This should just be an else because I know it must be times. It saves me a little bit of writing. Else multiply. Oh, I messed up here a little bit. I need 2 evaluates. Let me fix that. Yeah, I think that fixed it. Times evaluate. First x evaluate. Third x. Close my con, close my define. Okay. Hope that works. It feels almost too good to be true, right? Too easy. Okay. Assuming that I didn't royally mess this up, I'll move on to problem.